Hello, everyone. Good morning, good afternoon, and good evening. Dear author and invited guest, welcome to Technical Session 3A. Myself, Richa, and this session will be moderated by me. On the behalf of the Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the 9th World Conference on Smart Trends in System Security and Sustainability, WS4 2025, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom today and tomorrow. I hope you will enjoy the knowledgeful and interactive session through the day. In this session, we have 6 presentations. Each presentation will be given 12 minutes for presentation and 3 minutes for question answer. After 10 minutes, I will raise a general reminder. There is another request to all the participants that you will stay connected with the end of the closing remark. If you have any query and any update, write it to me in a chat box. Just before we get started, I would like to introduce our chair of this session.
Hello, colleagues. I will chair this session. I'm Marinka Ivanova from Technical University of Sofia. And as you know, you have 12 minutes for your presentation and some minutes for question and answer. So I would like to greet you at this wonderful conference. And my suggestion is to start this session. So please, the first presenter to share the screen and to start.
Okay, now moving ahead, we can call our next, we have one more session chair in this session, Dr. Durgesh Kumar Mishra. He's a director of Symbiosis University of Applied Science, Indore. He is also visiting faculty of IIT Indore, India. And he has 30 years of teaching and 15 years of research experience. He has published more than 100 papers in a referred international and national journals and conference, including IEEE and ACM conferences. Welcome to you, sir. And now moving ahead, we'll start with the papers. We can call our first presenter to present his paper on a review on a machine learning based LPWAN technologies for performance improvement, architecture, key challenges, and future directions. Paper presenter is S. Diane.
Hello, everyone. I am Asjani. And I can share my screen. Okay. Can you hear me very well?
Yes, we can hear you. And now we see your presentation.
Okay. Hello, everyone. My name is Asjane, and today I'm going to present you our articles entitled A Review on Machine Learning Based LP1 Technology for Performance Improvement, Architecture, Key Challenges, and Future Direction. The co-author of this work are Swan Diallo and Elhadji Malick Ndoye, both affiliated at Assane Seck University Ziguinchor in Senegal. The presentation follows these steps. Firstly, we will introduce, and in this section, the control of the article are drawn, and after the goals, the main objectives are defined. In 3-point overview of LP1 and machine learning, in the section, we will introduce 2 basic concepts of this work, LP1 and machine learning. And after approach for integrating machine learning into LP1, this section will provide different approach for the integration of machine learning at different level of the LP1 networks. In 5, current state of research into the combination of LP1 and ML. This section reviews the literature and draws up inventory of the state of research on the combination of LP1 and machine learning and analyzes relevant work exploiting this combination. And 6, discussion on the challenge of LP1 and machine learning based solution, the key challenge associated with LP1 and proposed solution based on machine learning techniques. And 7, conclusion will summarize the article. Let's start with the introduction. In the context of the Internet of Things, low power wide area network, as now LP1 network, have become an essential connectivity solution thanks to their lower energy consumption and ability to cover large area as now to long range. However, this network continues to show various performance limitations such as limited transmission capacity, node density management, adaptability to variable radio condition, and energy consumption improvement. In light of these challenges, incorporating machine learning into the structure of LP1 network offer promising prospect for enhancing their performance. And the objective of this work or of this article, the main objective of this work is to explore the integration of machine learning techniques into LP1 network while taking into account their specific characteristic and constraint. It focuses in particular on the use of machine learning to improve the management and optimization of this network in order to maximize their performance and efficiency. Now let's present two concepts essential of this work or two concepts important of this work, LP1 and machine learning. Firstly, we present the LP1. LP1 brings together a range of technologies such as LoRa, Sigfox, and BIOT, and so on, dedicated to the Internet of Things. LP1 are characterized by long transmission range, low energy consumption, scalability, and low cost of terminal device. So scalability means the possibility of the gateway to take account many of end devices. The physical architecture of end-to-end LP1 is essential composite of 4 entities. So terminal nodes or user equipment, relay node, also known as gateway or base station, a network server, and application server. The terminal nodes are connected with one gateway or many gateways and can send a data of gateway or receive a data from the gateway. The gateway is connected with a network server, and network server communicate with application server. So let's start the machine learning. Machine learning is a subset of artificial intelligence. The basic idea behind machine learning is the use of an algorithm that improves its performance by learning from data. We have four learning approach. The first is supervising learning. Supervising learning is a paradigm in which given data set and algorithm assign a value now as the computed output to each training example, and the difference between the computer output and the target output initially assigned to each training example must be minimized. After we have unsupervised learning, the supervised learning is a machine learning type of machine learning in which the training data is not explicitly labeled. In other words, there is no outcome for the training data. After we have a reinforcement learning. Reinforcement learning is an agent take parameter from its environment as input and undertakes an action as output. This a reward or penalty is assigned to the agent, immediately inform it of the results by its environment. And after we have a deep learning, also known as deep structured learning or hierarchical learning. Deep learning relies on algorithms that are primarily used for making prediction, performing classification, or assisting in decision making based on data. Deep learning is characterized by nonlinear multi-layer processing and can be either supervised or unsupervised. The nonlinear multi-layer processing means that the input to each processing layer is the output of the preceding layer. And after we propose an approach for integration ML into LP1. The ML algorithm can be implemented at different level of the network depending on the available hardware capability and the targeted optimization objective. On the end nodes is a gateway or the network server. ML algorithm implemented in the end nodes can enable able to make decision, adapt to the environment and self-configuration for the end nodes. And if ML algorithm implemented in the gateway can be enable data filtering, adaptive configuration, interference detection. And so if ML algorithm implemented in a network server can be enabled and not profiling, make decision for and not improvement management of all network entities. In figure 1, we have LP1 architecture integrating ML algorithm of different level and nodes for a gateways for B, and a network server for C. And here we have current state of research into the combination of LP1 and ML. Analysis of proposal-based integration of ML and LP1 studied in the literature. Figure 2 shows a different machine learning approach on KLP1 dimensions. The study is based on over the 80 paper from the literature that explores the integration of LP1 and ML. Due to the increasing availability of labeled data sets, the supervised learning is the most widely using approach. LP1 network show in the figure 3. We can remark the supervised learning is the most widely using. And LP1 characterized by their high dynamic and frequent state changes favor the use of reinforcement learning in resource allocation, enabling the network to adapt to variation in the network state. And deep learning is used for complex issues such as interference management, LP1 security, traffic management, and resource allocation. In figure 3, we have a classification of study by type of learning or K dimension of LP1. Illustrate the distribution proposal on LP1 technology in the paper study combining both LP1 and machine learning. So the LoRa technology stands out the LP1 technology most associated with machine learning in the work analyzed is to deploy, and LoRaWAN is open source to make LoRa an ideal solution for a wide range of use in the Internet of Things. NBIT is the second most studied LP1 technology in combination with machine learning. Its strong presence in the paper listed in explained by its integration with existing cellular infrastructure, ensuring extensive network coverage, good quality of service, and efficient spectrum management. Sigfox is the LP1 technology less used in associated with machine learning compared with LoRa and NBIT. This low adoption may be explained by its dependence on a proprietary network, which limits deployment flexibility. In figure 4 is a bar chart illustrating the distribution of LoRa study according to K network X and the machine learning approach. Using reinforcement learning dominated the other approach to optimize resource allocation at its enable adaptation to the network environment. Deep learning is more wide used to manage network traffic and minimize interference because it predicts network behavior based on labeled data. Reinforcement learning is relevant for dynamically adapting sensor activity cycle and optimizing energy use. Supervised learning is a type of learning often used to improve the localization accuracy of IoT object in a LoRa network by analyzing radio signal and estimating position. To ensure the security of LoRa network, supervised learning is often used to categorize attack type and improve network protection. Also, unsupervised learning and deep learning are used in few papers. Some area for optimizing LP1 VA is the integration of ML. And the decision to focus of these three areas is based on their direct impact on the performance and optimization of LP1 network. particularly in the context of the connectivity, capacity, and energy consumption constraints specific to these networks. Traffic management, the first axis is traffic management. Traffic management, there are two types of traffic in LP1 network, regular traffic and event-driven traffic. ML techniques have been proposed in the literature to solve problem arising from high traffic in LP1 network, or to exploit the huge amount of data coming from high traffic to improve LP1 performance. The second is resource allocation. The performance of wireless network, especially LP1, where the frequency band is shared with other technologies, is highly dependent on the way network resources are managed. In addition, LPWAN networks are highly dynamic as totally random factors such as changing environmental condition, signal from external source. User mobility can often influence network performance. ML technique can be a credible alternative for solving resource allocation problems. And the last is energy efficiency. The cost associated with maintenance, in particular recharging or periodic manual replacement of batteries, represent a significant barriers to large-scale deployment. As a result, advanced power management strategies are essential to extend the life of LP1 device and ensure their efficient operation. Machine learning techniques represent a valuable tools for reducing power consumption and maximize energy efficiency. Discussion on the challenge of LP1 and ML-based solution. LP1 are challenged by a number of factors affecting their performance. These include constraint interference, vulnerability to attack and anomalies, and latency issue for real-time application. To overcome this limitation and optimize network performance, machine learning is a potential solution. Resource constraint, as a result, running machine learning models directly on nodes is computationally complex and pose a major research challenge. Potential solution to this challenge could be model compression algorithm or federated learning. Interference and coexistence. Supervising or unsupervised learning algorithm can be used to predict period and area of at high risk of interference by analyzing historical data collected on transmission channel uses. Based on the prediction results, effective interference reduction strategy can be adopted by node, such as avoiding congested channel or delaying access to the transmission channel. Also, reinforcement learning can contribute to interference mitigation in a dynamic and adaptive way. Security and anomaly detection. The LP1 environment is dynamic and evolutive. Static security mechanism, ineffective learning can be helped detect, prevent, and respond to security. Zurich, both supervised and unsupervised learning can help detect anomalies by identifying unusual behavior or events. Latency and real time. Latency is the time it takes for a packet to be transmitted from one network entities to another. And real-time application require data to be transmitted and processing in a very short time, can dynamically optimize the word cycle of not according to requirement using
Dear presenter,
reinforcement learning.
dear presenter,
Yes,
you have last 2 minutes.
okay, thank you. Algorithm to learn the optimal node activation and snooze policy. Supervised learning algorithm to determine the period when traffic is high, like test to identify the best time. For data transmission, can use historical data on network traffic. Conclusion. This study illustrated the potential machine learning improve LP1 by overcoming some of the shortcomings of traditional approach while taking into account the specific feature of this network. Based on in-depth analysis, existing work has been classified into the following area: traffic management, dynamic resource allocation, and energy efficiency. These axes constitute field of study for optimizing LP1 using ML techniques by managing central issues such as resource constraint, interference, security, and latency. This review helped to fill a gap in the literature by offering a version of how LP1 can be combined with ML techniques to optimize this network. Thank you for your attention. Thank you.
Okay, thank you so much for your presentation. Colleagues, do you have any questions? Professor Mishra?
Yeah, I have one question. This why you think about this AI ML is better than the others?
Can you repeat your question, please?
Hello.
Yeah.
Yes, I am having one question. Danny, why this approach is better than the traditional one?
I can't hear very well
Why
this
this
question.
approach?
Professor Mishra, we cannot understand your question, maybe some technical problems. Could you write your question in the chat and
Exactly.
our presenter will answer then?
Exactly. Exactly. Thank you.
Ma'am, Professor Mishra is rejoining again. If you have any question, you may please ask.
Yeah, okay. Professor Mishra will email to you with the question. Thank you so much again for your presentation. Thank you.
Thank you.
And I would suggest to go to the next presenter. And this is Ranjit.
Now we can call our next presenter.
Okay.
To present is a paper on basal plant leaf disease classification using hybrid models. And paper presenter is Ranjit Vasant.
Hello, ma'am.
Hello.
Hello. Okay, ma'am. So I'm going to present this paper.
Okay.
Yes, wait a minute. Is my screen visible, ma'am?
Yes, it's visible.
Okay. Okay. So good afternoon, everybody. So our research paper topic is basal plant leaf disease classification using hybrid models. So let's start with the introduction of our topic. So, holy basil or tulsi is a revered medicinal plant in Ayurveda, valued for its therapeutic properties. However, its cultivation is hindered by various plant diseases that affect yield and quality. So, this study proposes a hybrid deep learning model combining EfficientNet B0 and SVM for early and accurate classification of basil leaf diseases, achieving a high testing accuracy of 98.86. So, our problem statement is to design a holy basil leaves disease detection system for farmers using deep learning models to accurately identify and classify diseases, including downy mildew, fungal infections, leaf spot, and fusarium wilt, enabling timely intervention to minimize crop loss and preserve medicinal quality. So, the objectives of our projects are to first enable farmers and growers to easily detect basil leaf diseases early using a sample image upload, reducing crop loss and increasing yield quality. Next is to develop an accurate and efficient model for early detection and classification of basil leaf diseases using image based data. And third is to enhance dataset performance using data augmentation techniques for better generalization and model training. Next here, so before developing our approach, we first referenced some literature papers earlier for to see for related work and to gain some knowledge. So here I have prepared a literature review of 6 papers. So here I have mentioned the title of the research papers along with their authors and the overview showing what work has been done in each of the research paper and what their results were. So Next here is the architecture diagram of our model. So we have actually used an efficient net B0 model for our approach. So as an input, we are giving a 224 cross 224 pixel leaf image to this efficient net B0 model for feature extraction. So what this efficient net B0 model is actually, it is a pre-trained CNN model by Google, which is trained on ImageNet dataset, and this it uses these weights to make predictions from our data set. So what happens actually is it extracts the uh, features from our data set, then pass it to, and then the average pulling is done on those extracted features to reduce its dimensions. And then after that, some of the learning layers are added to a model to increase its performance. So we have added a dense layer and a dropout layer for this to increase our performance and to avoid the overfitting of the model. And the next is the output layer, which is which is a softmax layer. So this layer actually does the classification task by giving the probabilities of each deceased class. So actually, this architecture showcase how a pure efficient net B0 model works. But in our approach, we have used an hybrid approach. So what we actually did is we replaced this output layer of activation function with a traditional classical machine learning classifier. And for that, we have used three classifiers: super vector machines, k nearest neighbors, and random forest classifiers. So what this hybrid approach actually do is it uses efficient net B0 model to extract the features from our data set and then pass it to this classical machine learning models for classification purposes. Next is why we use the hybrid models. So our data set was a small data set. So, and with small data sets, generally what happens is CNN dense layers often overfit, whereas classical machine learning classifiers can generalize better on extracted deep features due to their strong decision boundaries. And later, for improving the performance, we fine tune these CNN feature extractors to further adapt filters to basal leaf disease specific patterns, which improve the overall accuracy, recall, and F1 score. Then next about the data set. Originally, we had 803 images of basal leaves with 5 categories, and among which 4 were the disease categories, which are namely leaf spot, fusarium wilt, downy mildew, and fungal. And the fifth class was of healthy leaves. And we did a augmentation on this data for training purposes. And after augmenting this data, our number of images increased to 4,818 images, and then we use this for training our model. These are some sample images from the data set. Then for evaluating our model, we use this concept of five-fold cross-validation, in which we splitted the data set into 5 equal parts, and then each fold uh, in this approach, what actually happens is like each fold is once used for testing, and the remaining folds are used for training. So like this, it calculates the accuracy, or you can say the CV score 5 times, and for the final performance, the average of all these CV scores is considered, and based on that we can evaluate our performance. Then this is a graph which shows the learning curve of our fine-tuned efficient net B0 model. In this graph, we can clearly see how training accuracy and the validation accuracy is increasing along with the increase in the number of epochs while training the model. Then these are our final training accuracy, validation accuracy, and testing accuracy. So in our research, what we actually did is we trained a total number of 6 hybrid models. and the one which performed the best, we use that as our final model. So for feature extraction, we used two CNN pre-trained CNN models, EfficientNet B0 and MobileNet V2, and applied machine learning classifiers on both of them. All these three machine learning classifiers, which are SVM, KNN, and random forest, on both of them. So in total, we trained 6 hybrid models, and our best performer was EfficientNet B0 with SVM model, which provided us the testing accuracy of 98.86 percentage. So this is so here is the table, and this table shows us the comparison between different classification models. So in this table, we have included some of the models from the previous studies. Like these top 6 models are from our referenced literature papers, which we considered while studying, like what models they used and what accuracy they got on that models and in which year that paper was published. We have mentioned all over here. So top 6 models are from the previous studies, and this last 6 models are our proposed models. And in that too, we have considered this last model of efficient at B0 plus SVM, which is also a proposed solution. And we have used that in our project, and it gives us the accuracy of 98.86 percentage. And for the future scope, our current data set consists of only 803 images, which we augmented to train our model effectively. And in the future, we plan to expand this data set, which will not only improve the model's robustness and generalization, but also reduce the need for the data augmentation. So that's it with the presentation. Thank you.
Thank you so much. Questions, colleagues? Professor Mishra? Cannot hear you.
So we can't hear you.
I think that there is some problems with connection.
Hello. Sir, is this possible to write it? Hello. No, sir, you're not audible. So is there any possibility to write a question in the chat box?
Okay, I have one question. It is related to these percentages about 100.
So your voice is not audible. So I request you kindly write it your question in the chat box. Okay. Hello. Mitali,
Yes, ma'am.
sir's question is wait a second. How to compare your models?
Like with others.
Yes, how to compare with your models? This is the question from our chair.
Like we actually referenced two papers which were working on the same problem statement as ours. So we compared with them actually, our models. Like our model was giving more accuracy than them.
Okay, and how do you explain this very high accuracy about 100%?
Ma'am, that is the training accuracy. So actually it means that the training accuracy is 100%. Like the data is training, like our training accuracy is 100%, right? So which means that our data set is able to consider all the features and is properly able to train on that data. And the testing accuracy is 98.86. So
Okay,
while
thanks so much.
testing, it gives, yeah.
Yeah, thank you.
Yes. And also, the sir asked the question of comparing with your model. So actually, I want to tell about that. So the paper, we referenced two papers, and we actually tried to compare with them, and they were using the similar data set with the same diseases. Their data set was very similar to our data set. That's why we compared our results with them.
Thank you so much.
Thank you.
Thank you, Mitali. And now moving ahead to our next presentation. To present her paper on Gen Z and Green Shift, a TBP and ISM MIC based structural analysis on electrical vehicle adoption in India. A paper presented is Husna.
Yes, hello. Good evening, everyone. May I start my presentation?
Yes, you may please start your presentation.
Okay, can you all see my screen?
Yes, it's visible.
Good evening, everyone. I'm Husna Bhayani, and I'm going to be presenting on my paper titled Gen Z and the Green Shift, a theory of planned behavior and ISM MICMAC-based structural analysis of EV adoption in India. So the flow of the presentation goes as follows. I will start with the need for my study firstly, followed by introduction, problem statement, research objectives and methodology, and then I'll close with the findings, conclusion, and future scope. So the need for the study. We've considered the global context of pollution caused by EVs. So transportation by traditional fuel vehicles, transportation alone contributes 23% of global carbon dioxide emissions, and India is the third largest emitter, recording 4.2 gigatons in 2023. And so EVs are crucial to meeting India's net zero goals and fulfilling the key sustainable development goals. So it's not just a technological shift, but it's needed for its sustainability goals. Personally, on a personal note, our research is guided by the triple bottom line principle, which says that businesses need not necessarily only focus on profit, but also to the people and planet and the society. And our interest in understanding Gen Z's roles as environmentally conscious and tech-driven adopters. We aim to integrate behavioral insight with structural modeling for actionable strategies. So there was a striking research gap because all the previous studies emphasized on the infrastructure and technology of EVs, not the behavioral dynamics. So, and limited India-specific research existed on Gen Z's motivations for EV adoption, as it still remains inconsistent. Scarcity of research, there was scarcity of research that combined thematic analysis along with ISM MICMAC for interfactor mapping of the factors. Okay, so the introduction. India's EV market is expanding and is driven by government incentives and electrification targets. Under the Paris Accord that India signed, it aims to reduce its carbon emissions by 30 to 35% by 2030, and EVs plays a strategic role in this aim. Despite momentum, there are still challenges that persist among Indians, which are high upfront costs because India has a price-sensitive market. There are limiting charging infrastructure yet, and lifestyle integration hurdles. So the sustainability link, EV plays a pivotal role in India's transition to green mobility as it reduces fossil fuel dependence and helps combating rising urban pollution. Adoption aligns with long-term environmental and public health goals as well. So at the beginning of our research, we made a mental model of what we thought the research is going to be, where we've looked through all the factors influencing green mobility among Gen Z. For example, awareness, social influence, infrastructure, education, economic factors, etc. Our problem statement is that India contributes 7.08% of global GHG emissions, and transportation is the fastest growing contributor. So, and over 2 million annual deaths in India are linked to air pollution. EVs are essential for emissions reduction, yet Gen Z adoption remains inconsistent despite policies as well as subsidies. The research lacks the behavioral insights, which limits the effectiveness of targeting certain audiences with interventions about EVs. So, bridging this gap, we believe, is critical to promoting sustainable mobility and improving public health overall. So, we had two research objectives. Our first was to identify factors, analyze key behavioral and environmental drivers influencing Gen Z's EV preferences, and how are the factors interconnected, and to offer actionable insights using ISM MICMAC analysis for accelerating adoption. Methodology. So our research design includes mixed qualitative methodology, combining first thematic analysis and then ISM MICMAC modeling. These were used to explore both behavioral insights and intervariable structural relationships. So we used stratified purposive sampling, ensuring representation from diverse Gen Z groups. We conducted 24 semi-structured interviews across urban and semi-urban Indian regions. We discussed motivations, perceptions, as well as barriers to EV adoption with all our participants. So data analysis, the thematic analysis was guided by theory of planned behavior, which studied attitudes, norms, and control. The consumer culture theory, the cultural or social consumption patterns, and the analysis was supported by tools like NVivo, SaaS, Mermaid, and JMP. The structural modeling. So ISM mapped the relationship among the 6 expert validated variables. Thematic analysis gave us our factors, but ISM studied the interrelationships between them. Further, we used MICMAC analysis that categorized variables by driving and dependence power to form a hierarchical model of influence. So in our thematic analysis, we identified 3 themes, which were: first is environmental responsibility, that our Gen Z participants expressed a strong moral commitment to reducing pollution and making sustainable life choices. Second was economic barriers, that was that the high initial purchase costs and long-term affordability concerns limited EV appeal among price-sensitive consumers. And lifestyle integration, that it needed seamless adoption depends on compatibility with daily routines, charging ease, as well as overcoming mobility constraints.
Lunch, breakfast, dinner.
Totally kindly arrange food for the same from 21st to
For the given itinerary. Itinerary दी हुई ना अपनी, हम डेट लेने जरूरत नहीं है. Itinerary दी 21 को शाम को आएंगे और
बुलाएंगे from
Can I continue?
Yes, sorry for interruption. Please continue.
Yeah. This was a thematic analysis process. So thematic analysis works like we take qualitative interviews with our respondents. We collect the major statements, the prominent statements. We find the keywords and we code them. And further, we get the themes. So we've gotten 3 themes. The first 2 codes were sustainable and clean air, by which we got environmental responsibility. And then come economic barriers as well as lifestyle integration from the statements and the codes. The ISM analysis, they give us the SSIM table, which shows us what do they think, what influences what is the relationship between the variables, and the variables are presented vertically as well as horizontally to get the relationship between each of them. We have interviewed buyers, experts, academicians, as well as professionals for the ISM analysis. This SSIM table is further converted into a FRM table, where these letters are converted into binary form so that we can get to know their driving power as well as dependence power. Further, the ISM model of EV adoption shows us the hierarchy, and then it was further converted into a MICMAC scatter plot, where we can see the driving and dependence power in these 4 quarters. The structural insights from ISM MICMAC are that sustainable perception, one of our factors, was identified as the strongest driver of EV adoption. Second, driver experience and mobility constraints were identified as highly dependent factors, whereas clean air benefits and sustainable innovation acted as the linkage variables, both influencing as well as being influenced. The model confirmed a clear hierarchy of influence, stating that sustainable perception is independent and driving experience is most dependent between these factors. So discussion and implications. Our theoretical contribution combines thematic analysis and ISM MICMAC for a behavioral structural view. It is grounded in theory of planned behavior, consumer culture theory, and it links Gen Z's values, practicality, and identity. Its managerial implications are that it highlights sustainability and social identity through Gen Z channels. To offer flexible pricing models, for example, subsidies, leasing, trade-ins, etc., to strengthen the charging infrastructure via public and private partnerships, and emphasizing experience and innovation, for example, smart features, fast charging, to attract the Gen Z to buy EVs consistently. Our SDG linkages, our social sustainable development goals. Sustainability perception, one of our factors, relates to SDG 12, which is responsible consumption and production, as well as climate action, SDG 13. Cost efficiency relates to SDG 8, which is decent work and economic growth. Mobility constraints relates to SDG 11, which is sustainable cities and communities. Clean air benefits relates to SDG 3, which is good health and well-being, as well as affordable and clean energy. And sustainable innovation relates with SDG 17, which is partnerships for the goals. So our conclusion, our key takeaways are that Gen Z adoption is strongly driven by sustainability perception as identified previously in our ISM analysis. Cost and structure remain significant barriers for Gen Zs to purchase EVs. Driving experience and innovation are gaining more importance, and ISM MICMAC framework provides a policy and marketing roadmap for EV adoption. A future scope of the study is demographic expansion, of course, to include millennials and older generations to compare generational adoption patterns and widen the policy relevance, and applying quantitative validation methods like SEM and analytical hierarchy planning, and to investigate emerging technologies such as fast charging and EV sharing. These are our references, the papers that we've referred. Yeah, thank you. I welcome any questions or insights anyone would like to share.
Thank you so much.
Yeah, am I audible?
Yes, sir.
Yeah. Why you mention this EV only for the Gen Zs, to motivate the Gen Zs, not the others?
We wanted to focus on the Gen Zs as they are the most sustainable people, and they are the new audience right now for sustainable. They are more tech savvy and they tend to trust EVs more.
From which country? For which country you taken the data?
India, sir.
Why you say India is Gen Z is a very big crowd? The other than Gen Z is also a very huge crowd that go for the EV.
Yeah, Professor, this is Professor Nagaraj here,
Yeah.
a co-author in this paper.
Yeah, please, Nagaraj.
Yeah, thank you for your insightful suggestions, sir.
Right.
The reason why we opted for a Gen Z is because India is considered to be the most demographic dividend country.
Yeah.
Where predominantly the young population is driving the entire thought process.
Yeah.
And sustainability is very new when it comes to Indian entire developmental agenda.
Yeah.
And Gen Zs are the fulcrum of the entire development.
Yeah.
And in view of that, we have opted for a Gen Z.
Okay, but why we are going to restrict on the Gen Z? The same thing you can go for the others also. My question is that.
See, we can go with others. The majority of a population where demographic dividend is there, where our Prime Minister is also very vocal with regard to demographic dividend. Hence, that made us to think about the usage of a Gen Zs, because as per the latest RTO information, Road Transportation Department information, every fifth vehicle in India is EV, being brought by the youngsters, and there is a lot of relaxation given on the licensing and other things. That's
Okay.
where it is driving us.
Okay, thank you, thank you, thank you, sir.
Thank you very much, Professor.
Okay, I have one question. What is your observation about the infrastructure in India?
I didn't get you, ma'am. Can you just help me to recollect?
Yeah, I mean, what is the infrastructure for electrical cars in India? Are all this ready and which percentage is ready?
It's yet very minimalistic level. It need to be developed. Now the new smart companies are coming up with startups where the entire infrastructure is slowly picking with regard to charger, charging equipments and other things. But it's hardly within 10%, ma'am, as per our literature.
Okay, thank you so much. Thank you for your nice presentation.
Thank you very much, ma'am. So kind of you for your inputs.
Thank you.
Thank you so much, presenter, for your presentation. And moving ahead to our next presentation. To present his paper on geomechanical characterization of soil for bearing capacity assessment in the Belen sector of Loja, Ecuador. Implication for urban development. Paper presenter is Tyrone Alexander. Dear presenter, are you in meeting? Any co-author of this paper? Shall we forward to the next presentation? To present is a paper on improving heart disease diagnosis through a modified logistic regression model with a control sigmoid scaling. A paper presenter name is Ranjit Vasan. Dear presenter.
Yes, good afternoon, ma'am.
Very good afternoon. You may please start your presentation.
Yes, is the screen visible?
Yes, it's visible.
Okay, good afternoon, everyone. I am Unnati Shenge, presenting on behalf of my team. Our paper with ID 20 is titled Improving Heart Disease Diagnosis Through a Modified Logistic Regression Model with Controlled Sigmoid Scaling. So, we know that cardiovascular diseases are one of the leading causes of death worldwide, claiming millions of lives each year. And therefore, early diagnosis and accurate risk prediction are essential to save lives and reduce healthcare burdens. So, our work focuses on developing a predictive model that estimates the likelihood of developing heart diseases using patients' health parameters. And unlike black box models, we choose logistic regression as it is widely used in healthcare due to its interpretability. But we made certain modifications to improve its accuracy and reliability. So, next, the data set, we use the Framingham Heart Study dataset, which is available on Kaggle, and it contains 4,238 records and 16 features. The features include age, gender, blood pressure, cholesterol level, diabetes level, glucose level, heart rate, among others. And our target variable is 10 years CHD, which indicates whether a patient is likely to develop heart disease within the next 10 years. Next comes the data processing. So before training the models, we performed several processing steps like handling missing values. We used a simple imputer to replace missing values with the mean of each column. Then we feature scaling. We applied standard scalar to standardize numerical features, giving them zero mean and unit variance. ensuring all features contribute equally. Next, data splitting. Finally, we split the dataset into training and test sets using trend test split to evaluate performance on unseen data. Next, we tested a range of standard machine learning models, including logistic regression, k-nearest neighbors, decision tree, random forest, support vector machine, and XGBoost. To evaluate these models, we focused on several key metrics, that is accuracy, the overall percentage of correct predictions, precision and recall. These are crucial for medical diagnosis. Precision tells us how many of the positive predictions were actually correct, while recall tells us how many of the actual positive cases were correctly identified by our model. We also used F1 score and ROC AOC score. This provides a single number to evaluate the model, balancing precision and recall, which is vital for this type of problem. Next, as you can see from our results table, standard models like random forest and SVM show promising accuracy, with random forest achieving 84.98% and SVM with 85.06%. However, their recall and F1 scores were relatively low. Therefore, to push performance further, we implemented a custom logistic regression model from scratch, where we introduced modifications to improve stability and generalization. This approach gave us both flexibility and control over the learning process. So our proposed method introduced several enhancements to the original logistic regression, that is modified sigmoid activation. So what we did was we used a scaled and shifted sigmoid function to improve the numerical stability and flexibility. Then L2 regularization. This penalizes large weights, reducing overfitting. Then we also used early stopping with patience, that is, training automatically stops when no further improvement is observed. Next, learning rate decay, that is gradually decreasing the learning rate so that it improves the convergence. And also loss curve visualization, where we tracked and plotted the loss during training to monitor performance visually. These modifications allowed us to build a more robust and accurate predictive model. So our custom logistic regression model achieved a test accuracy of 85.14%, which was higher than the baseline logistic regression and the other tested models. This demonstrates that even with a relatively simple model, by carefully adjusting the activation function, optimization process, and regularization, we can significantly improve predictive performance in healthcare applications. Next, to conclude, I would say that our modified logistic regression approach proved to be the most effective and achieving an accuracy of 85.14%. The model is both accurate and interpretable, making it a potential decision support tool for healthcare professionals in every diagnosis and prevention of heart disease. In the future, we also plan to test the model on larger and more diverse data sets and possibly extend it with hybrid approaches that combine logistic regression with deep learning techniques. Thank you. Thank you for your attention.
Thank you so much. Colleagues, do you have questions? Okay, I have one. As I saw that you demonstrate that several other algorithms are useful in this task, and do you use them for your experimentation, or you just focus on logistic regression?
No, we also used other models like random forest decision tree. We used them, we also saw the results, but they were not very good. And that's why we wanted to work on logistic regression, as it is useful in medical sector, and therefore we focused on logistic regression and tried to improve the accuracy.
Okay, then maybe I would suggest to see your title of the presentation and of the paper, because it is only mentioned the logistic regression model, but actually you use several models and compare their accuracy, and maybe to be more accurate, this title could be include some machine learning models, I would suggest. And also about the data, what kind of data? Is this free data set, or it is your own data set? And also how you split this data to training and to testing, because I cannot see this in your slides.
Yes, ma'am. It's a free data set available on Kaggle, and we have split it in training and testing for training our model.
What is the percentages on training and testing? How do you split data?
अभी पता है 6 महीने सुबह से रजिस्टर कर चुके और इनको क्या होता है, मेरे को तो पता ही नहीं, आपके डिपार्टमेंट वाले इन्फॉर्म ही नहीं करते मुझे, बस मैंने तो सुना है कि लोग आ रहे हैं इसरो वाले।
Maybe 18% for training and 20 for testing, or
और सीट में रिसोर्स की स्टेटमेंट है।
Yes, ma'am. We have used 70% for training and 34% for testing.
okay. Thank you so much. Thank you.
Thank
Other
you, ma'am.
questions, colleagues?
किसी पागल तरह की बातें कर रहा था कि सुबह उठ के कहाँ जाएंगे, इलॉजिकल। तो अजित बोलता है मेरे साथ तो ऐसे डील करते हैं, मैं तेरी अलग क्यों नहीं है उससे, मैं तो लेके जाता हूँ।
Sir, any question regarding the presentation?
I think presentation is good. I think most of the question asked by this Malinika, okay, and it's a good presentation. You have to take care about this, so you have to change the title, I think so. What the suggestion is that, okay? So
Yes, sir.
next time you have to take care of this, okay? It was very nice presentation and nice questions. Right? Thank you.
Okay, sir. Thank you.
Thank you so much, Unnati, for your presentation. Moving ahead to our next presenter. To present his paper on managing cybersecurity risk of human-machine interface and adaptive dynamical system analysis, Jan Terror. To your presenter.
Yes, I'm trying to share.
Okay.
The first joint authors, they have their holiday, so they recorded a video that I can play. So then after that, I can try to answer some questions. Do you see the video?
Yes.
Welcome. I'm presenting our paper on managing cybersecurity risks of human-machine interfaces, specifically our scenario on Stuxnet. Stuxnet is a specialized computer worm designed to target supervisory control and data acquisition systems used in industrial controllers. The Stuxnet worm was discovered in June 2010 by a Belarusian cybersecurity firm during an investigation of unexplained computer crashes. Intelligence analysis strongly suggest that Stuxnet was a joint operation between the United States and Israel, specifically designed to sabotage Iran's nuclear program. Given the air-gapped architecture of the nuclear facility, security researchers conclude that Stuxnet was most likely introduced through an infected USB drive. Stuxnet included 4 zero-day vulnerabilities. These exploits exploits targeted first a Windows vulnerability, enabling automatic malicious code execution from USB drives. Second, a window print spooler service flaw allowing network propagation through shared printers. And lastly, two separate privilege escalation exploits that bypass security restrictions to gain elevated system permissions. The worm specifically targeted Siemens SCADA systems used in industrial controllers. Upon infection, Stuxnet analyzed systems to identify whether they matched its target profile. If the system was not a match, the malware remained dormant to avoid detection. Once Stuxnet identified appropriate targets, it activated and controlled programmable logic controllers managing physical industrial processes. The worm first monitored normal system behavior to establish baseline operations, then systematically altered control logic to force machinery, in this case centrifuges, to operate outside safe parameters. During this sabotage phase, Stuxnet falsified sensor data and operational feedback, preventing human operators and automated safety systems from detected manipulation. This was done until physical damage became irreversible. This is the network model. It shows how the attack flows from one state to another and highlights the key transition points that connect major steps. This table shows a network model of a cyber-physical attack divided into two layers. The first layer is the base level, which maps out the main stages of the attack. It starts with the initial compromise and moves through the steps the attacker takes to gain control, manipulate the system, and cause physical damage. Each state represents a key moment in the attack, moving from digital access to operational disruption. Rather than viewing the attack as a single event, this model breaks it down into a chain of actions that build on one another. It highlights how attackers don't just exploit the system once, they move carefully through stages, escalating their control over time. This includes hiding their presence, altering system behavior, and ensuring their changes go unnoticed by operators. The second layer is the self-modeling level. It contains transition states that show how one major step leads to the next. These transitions are important because they reveal the attacker's strategy, how they move from software renaissance to logic injection, or from local infection to network-wide spread. By modeling these transitions as their own entities, the system helps explain not just what happens, but how and why each state connects. Overall, this structure gives a clearer view of how a complex attack unfolds and helps identify the moments where detection or intervention could stop it before real-world damage occurs. Now, we've conducted several simulation experiments as part of our analysis, each one exploring different configurations of the attack scenario. The values we used were selected based on thorough background research, which is detailed in our report and integrated into the model. In this particular simulation, we observed some striking insights. Let's walk through the results step by step. What you're seeing here is a time-based activation graph of the different states in the attack model. The horizontal axis represents time and the vertical axis shows how active each process is, from 0 meaning inactive to 1 fully active. The simulation begins with the initial breach of the human-machine interface triggered through a 0-day vulnerability. This is the spark that initiates the chain reaction across the system. From there, each curve in the plot tells a part of the story. We observe the malware being executed, the installation of a rootkit to stay hidden, and then the malware begins scanning and targeting the programmable logic controllers. Eventually, it injects malicious logic that will lead to physical sabotage. By the time we reach X14, which represents the point where actual physical damage begins, the attack has spread through the system. Notice how many of the curves sharply rise between time steps 5 and 10. That marks the point where the attack intensifies and moves from software-level compromise to real-world consequences. Meanwhile, operator awareness does not increase, reflecting the stealth of the attack. The system continues to function under the illusion of normalcy, even as damage accumulates in the background. By step 20, most states have reached full activation, indicating total compromise and system failure. This simulation helps us visualize not only the sequence of events, but the quiet escalation and hidden nature of such sophisticated attacks, a reminder of how critical early detection and system hardening truly are. Now on to the what-if analysis. We performed several what-if analyses as a way to conduct evaluations on how different vulnerabilities and configurations affect the risk of a cyber attack, specifically modeled after the Stuxnet scenario. The goal was to assess how likely and how impactful various system configurations would be under attack. We did this by defining 3 key if factors, which are input conditions that represent possible weaknesses or system properties that can vary and influence the outcome. X1, how easy it is for attackers to compromise the system. X12, how easily the malware spreads across the network. And X11, how resilient the malware is once it's inside the system. For each factor, we define thresholds, low or high, and then ran simulation across all combinations. We then measured the what factor, which is the output variable that reflects the system's response. In this case, the activation of a critical system state X14 at time points 5, 10, and 20. The earlier X14 is triggered, the more dangerous the scenario. What we found is that when X1, the attack threshold is low, meaning it's easy for attackers to get in, X14 activates much sooner. In contrast, when X1 is high, this system shows stronger resistance. Next, we calculated the probability of each scenario based on assumed statistical independence and combined this with an impact scale from 0 to 10. This gave us a risk score. By time 5, the risk was low with early detection. By time 10, the risk jumped to 7, indicating critical system compromise. By time 20, risk peaked at 8, representing full disruption or data theft. The key takeaway shows that the lower attack threshold, the more significant the risk and timing is critical. Most scenarios showed that by time 10, the system had already reached a dangerous state. In this project, we combined role-based matrices and adaptive network modeling to analyze a cyber attack scenario. The network model captured the dynamic response to threats. Simulation and what-if analysis revealed how small changes in system thresholds impact risk levels over time. These insights emphasize the value of modeling adaptive behavior and reinforce the need for further research.
Okay, so I'm available for questions.
Okay, thank you for this presentation. The topic is really very actual and important in the area of cybersecurity. And I just wonder, what is the simulation environment? How you set up this environment?
Yeah, so we do analysis by complex system modeling, so dynamical systems, and that are also adaptive. And some years ago, I developed an approach based on networks. And I also programmed the software environment for it that is used for the simulations in MATLAB. And the idea is that the causal effects, that one thing leads to another thing, that there are kind of cascade of events usually in such processes. We consider both the human factors and also the infrastructure factors. Then the network describes the influences of the different things to each other. And by computing that over time, you can have the different type of dynamic patterns. What we also then do is to have learning or adaptation as a level on top of it. You saw the second level maybe in the picture. Then you have network characteristics like the connection rates or thresholds in logistic functions that can be also adaptive. And you can, for example, model measures. Like if you want to take a measure, then you make a threshold for something higher, for example. Or a counteraction, you make the connection rate stronger so that it's easier to activate a countermeasure. So in that way, you can have the direct processes modeled in a dynamic way, but also in an adaptive manner that you can learn from it and that you can take new measures that start to work in later phases. That's the whole approach.
Yeah, it's interesting approach because the situation is very dynamic, really, in cybersecurity ecosystem. Okay.
And learning is also very important that organizations become better over time for it. So that's also an important element.
Okay, thank you. Colleagues, do you have questions?
Jan, what's the difference between this privacy and security? What do you feel?
Privacy, you say privacy?
Privacy and security.
Well, maybe that's they are maybe related, but not always, I think. But I will have to think about it. Maybe that question is a bit philosophical.
Right, because this, when you go for the security and then all these things, privacy will comes in the picture, you know.
Yeah, it's if there are leaks, then of course the privacy is a problem because all data can become public.
Yeah.
But also people are monitored when we are. What I didn't tell, and also it's not in this paper, but in next work that we are doing in other papers that are currently developing, we try to develop an AI coach that monitors an employee whether the employee does follow the right types of protocol. They are developing now for cybersecurity more and more protocols and what to do in what situation.
Right.
And then we give an AI coach the knowledge of the protocol, and the AI coach observes the employee. Maybe that's already a privacy aspect here. Observes what the employee is doing, and if the employee is not doing, making a decision like the AI coach thinks it should be done, then it interferes and says, well, in such cases, there is knowledge so that you can make this type of decision.
Right. Thank you, Jan. Then it's a nice presentation.
Okay, thank you.
Thank you.
Okay, just wonder, what is your opinion about artificial intelligence in cybersecurity area?
It has different forms. So if it can help to detect anomalies, for example, that's one form. Machine learning can have a role. What we do is slightly different because AI has many phases and many different areas. We use the idea of people have expertise in terms of mental models in their heads, like they know the protocol to be followed in certain cases. And that's, you can call that a mental model from the area of cognitive science. And then the idea is that you should share such mental models, that you are on the same page, that you are not working against each other. And an AI coach that's on the development at the moment should also share such a mental model so that it can help the whole teams or the whole organization to get people on the same page and keep them on the same page, especially when there are stressful situations. Usually people start to forget part of their mental models. They just forget the protocols to follow them. And then in such cases, you can help. But that is just one form of AI. I think AI can contribute in different types of work, and also, for example, in the monitoring and anomalies detections, those types of things.
Okay, thank you so much. Thank you.
Okay, thanks.
Thank you so much, presenter, for your presentation. And we can call our last presenter, Ahmed Al-Zimani, to present his paper on smart home energy prediction using hyperparameter optimization and Gaussian process regression.
Can you hear me?
Yes.
Okay. Good afternoon. I will present our work on smart home energy prediction using Bayesian hyperparameter optimization of Gaussian progress regression. This research was carried out with my supervisors, Dr. Saptashi Das and Professor Marcus Muller. Here the outline of my presentation. I will start with the introduction, then explain the dataset, followed by the methodology and the results. Finally, we have the discussion, and we conclude with the some idea for future work. Smart homes rely heavily on accurate energy prediction. Good forecasting help manage the energy efficiency by reducing cost, avoiding waste, and reducing environmental impact. In the literature, researchers find that using renewable energy with optimization methods generate higher energy and lower the cost. This will lead to use less fossil fuel, and this will lead also to more control on air pollution, and this come back to clean sky, stable weather, which leads also again to higher energy production like solar or wind. Energy forecasting in smart home, city, farms depends on many factors, such as weather conditions, appliances usage, and human behavior. To handle this complexity, we use Gaussian process regressions, a powerful tool used in Bayesian machine learning model that can capture nonlinear pattern. Now let's talk about the data set. Our case study is a standalone microgrid system in Ray, a city of Norway. This system was developed under the European Union remote project, which focus in hydrogen-based hybrid microgrid. The dataset, the raw dataset has 45 variables for readings for weather conditions, energy production, energy usage for the year of 2020 in hourly basis. However, as we see in this relation table, some of these variables are redundant or have some linear dependence relationship. So we selected only 16 variables of these data sets. In our models, we have two targets. The total energy production, solar energy plus wind energy. This is our model, our first objective, a single objective. The second model will focus, the target is the consumption, the energy consumption in this smart home, using the same 14 predictors variables. When we plot the data set, we found that for the consumption, we found at the first 6 months, it's different than the last 6 months. This could be happen because maybe some because it's an experiment, maybe they change the energy system or any like behavior, human behavior. So to have more accurate results, we break our dataset into 2 groups. The first 6 months will be we'll call it the first half, and the last 6 months we will call it the last half. This is this plot for energy consumption. For protection, as we see in this blue line, these are all whole the year have the same pattern, except for December. Maybe there is some like holidays or just for 1 month. So we could like include it just 1 month of the 12 months. So we have 2 objectives, 2 groups, and we next I will explain the 6 pairs of our hyperparameters. So again, we use the Gaussian process regression. In this in our case study, we tried to tune 4 hyperparameters. Our way to tune these hyperparameters is like pairwise method. So in each model, we will optimize only two of these hyperparameters. The results show some improvement in when we only just tuning two of these hyperparameters as follow. First, in the prediction, the wind and solar energy production. We focus in the time, and we call it the cost of modeling these hyperparameters. We also, the other factor is the accuracy of these model. We use R square as the major factor. So these are the results of our tuning process. We from these graphs reflect these tables, and the coloring reflect the time. The higher is the higher time used. So from this graph, we can see sometimes we have the same similar result, or like very light difference, but with huge difference in time wise. Sometimes we see similar result, same times. No improvement between these pairs of hyperparameters. This in production part. In tuning these hyperparameters, we're using Bayesian optimization, a machine learning tools in the MATLAB, which sampling 30 samples from each configuration and find the optimum pairs of values for these hyperparameters. So these are our 6 pairs, and these are our hyperparameters. Next, in the consumption-wise, we found that in the first 6 months, the accuracy is below 50% because of the variation that we showed before. And for the last 6 months, we have some a good result above 70%, and different time wise. Sometimes,
Dear presenter, sorry for
yes,
interruption. You have last 2 minutes. Please conclude your
thank you.
presentation.
Thank you. So there is sometimes higher time with lower accuracy. So it's not always that the fact that taking more time means higher accuracy. This for consumption wise. These results show that human behavior in our case study for the first 6 months doesn't affect with the weather condition. This is the same optimizing for each pairs of our models. Future work. Our next step is ranking these pair of solution. As we see, there is a different between time and time cost or accuracy. There is some trade-off in some models, and sometimes the decision maker need to take this in his account. Next, in our future work, we will convert this process to an algorithm that can be process these tuning and finding the best solution for any user. Thank you. Any question, you are welcome.
Thank you so much. The energy sector is important for all infrastructure, and the measurement of consumption and production is also important topic. I'm wondering about kernel functions. Which one is the best solution for your task?
As we see, it's it's a random. It's different. We have 6 models. I'm not sure if is the slide show or is it white? Yeah. So for the kernel function, we have Artemetron 52 in some cases, or the 32 in some cases. So each time there is unfortunately, there is no consistent in one kernel function.
Okay, thank you. Questions, colleagues?
Hello. Yes. Is
Yes.
hello. Is the presentation is good. But what's your final research outcome for this?
At this moment, we propose how tuning hyperparameters is improving the results. Okay, in some cases. However, our goals were was expecting like very significant improvement. The improvement is like 10%, 20% between these first result and second try.
Okay. Okay. That is an improvement in your result, right?
Yes.
Okay. 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 Right. Okay. Thank you.
Thanks.
Thank you so much, presenter. And now we have concluded the session. I sincerely thank our author for the excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 9th version of all the previous of 8th version of the conference. We will be happy to have you in the next 10th version or 2026. All the presenter would be getting digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of Worldisful. I also thank our session chair of this session.
Okay,
Thank you
thank you
so
so
much,
much.
ma'am.
Thank you for inviting me to chair this session. Wonderful presentations, important problems decided with contemporary methodologies. And also, it's great that future work is also planned. Thank you again.
Thank you so much, ma'am. And thank you so much, sir, for your valuable presence.
Yeah. Thank
Thank
you. Thank you. Thank you, Richa, for inviting me for the same thing. Okay. And I hope the next conference version will also be very nice, and best of luck for the next. Thank you.
Thank you so much, sir. And I kindly request to all switch on the camera for a quick snapshot for the virtual conference. I request to everyone, please turn on the camera.
I can't because I'm driving.
Okay, no issue, sir. Thank you so much, everyone. Thank you so much, ma'am. Thank you so much, sir.
Thanks.